Good morning, everybody. Today we are going to see the remaining three lessons. Beam of deflections. 1 minute. Yes. Okay. Today we are going to see the remaining pending lessons. Deflection of beams, columns, and statically indeterminate beams. Okay. Last time I gave a small introduction. What is deflection of beams? And in this unit we are going to see only three topics. First one is slope and deflection at a point. Then double integration method and McCullough's method for simply supported and cantilever beams. Then another one is the definitions for double integration method and McCullough's method. Here I will give you the short formulas to keep in mind, but I will send you the derivations and you have a glance through it. Okay. So now, okay. Last time we have seen, right? What is deflection? It is nothing but a vertical displacement of here. Here is a simply supported beam. Here is simply supported structure, and here two columns are there, and here the beam is resting on these two columns. Now, when we apply a vertical displacement load on the beam, there is a deflection that happens. A deflection. The distance between the original form and the deflected deformed form is the key to find the deflection. Okay, and by this continuation, um yeah, here it is. Okay, now very simple. How they will ask questions at the slope and deflection at a point for cantilever beam as well as a simply supported beam. How we will find in case of problematic paper, or in case they want to ask a theoretical part, they may ask the questions like this. They may ask the formula. I will give the derivation part. You have a glance through it, and that is far 1 minute. You have a glance through it. Okay, so you have to just memorize the formulas. It's not here are the formulas. Yes, here it is. Only two beams, simply supported beams and cantilever beam. In case of simply supported beam, if it is a point load for deflection and slope, we must use these formulas, these two. In case of UDL, for the we have to use these two. And in case of cantilever, there is a small slight variation. In case of cantilever, when this load is applied at the free end, we have to use these two formulas. In case if the load is applied at the center, we have to use these two formulas. Okay, wow. And the next thing is a small example is given at the right side. For example, a simply supported beam made of steel having rectangular section, breadth 230 depth and 320 mm 230 breadth and 330 depth carries an uniformly distributed load. They have given a uniformly distributed load, and they have also given the load. We have to find the maximum deflection and the slope of the beam. It is at a point to find the slope and deflection at a point. Okay, wow. So in that case, which form? என்ன formula use பண்ணோம் அப்படின்னா, first we have to find, we know the formula that for cantilever, for simply supported beam, for point load minus 5 L by 4 L per 4 divided by 384 into E into Y. Okay, we have to keep the formula we have to keep this formula in mind, and before finding that we have to know the value of all these stuffs. So I is, we know for rectangular section to find how to find moment of inertia. So BD cube divided by 12. And next thing is, we know the load, we know the length, overall length, and then we know the, for steel, the value of E is 2.1 into 10 to the power 5 Newton per mm squared. You have to know this because it is useful for your forthcoming subjects GOS and forthcoming units also. Okay, E is the value of E for steel is equal to 2 into 10 to the power 5 Newton per mm squared. Okay, with the help of that, we have to find the deflection. Then for slope, also I have given the formula here. With the help of that, we have to find L cube divided by 24 into EI. All these given load, length, all these are given, so we have to find the theta form, we have to find the slope value. Okay, they will ask the question is this is third lesson is all about derivations and formulas and so much of problems. So in that case they might ask the formulas, they must confuse you, so you have to get thorough of these all these formulas. Okay, then they might ask in case of here simply supported beam, they might also ask cantilever beam. If the cantilever beam, if the load is up at the center, and what, how will you calculate the slope deflection, or in case they will give the slope deflection value and they will ask you to find the slope form, sorry, deflection value, and they will ask you to find the slope formula. Then in case of UDL, what formula you have to use, so you have to memorize, or else I will give you the notes, you have a, just a glance through it. If you can derive there, you can derive. Okay, this is the slope and deflection at a point. The next one is double integration and Macula's method. What is double integration and Macula's method? The difference is nothing but both are similar. But what we have to do is that only a simple thing is that only one equation. For example, we have to in Macula's method for bending the whole span of the bending moment, we will take the moment for the whole span. Okay, wow. In case of integration method, for a particular section we will cut the section. If it is like this, 1 minute, if it is like this, we will cut a section here, we will cut a section at anywhere you want, you can cut here or here, wherever you wish. So you will take this part alone, for this part alone you will find the moment. That is, they have given the writing different moment equation for different sections of the beam, wherever shear gets varied. Nothing but when the load is applied, the shear gets varied in simply supported beam. Yes, right? In that case, if we cut a section, we will find here. Okay, we will find the moment at the cutted part. The next thing is the most important thing is slope and deflection method, the double integration method, Macula's method, right? You will have a confusion in which case we must use double integration method and which case we must use Macula's method. So in that case, we have to we should have an idea. So double integration method is applied only when one load is applied. When Macula's method is used only when more than load is applied. Why it is given like this? In double integration method, we have, if you take a section, that are, I mean, 1 minute. Yes, double integration method, we have to use only one load. When one load is applied, then the Macula's method we should use when more than one load is applied. Okay, wow. Then these are the formulas for moment, slope, and deflection. It is derived like this. You know the integration method. So moment is equal to EI d squared by y, d squared y divided by dx squared. Then after integrating that, EI divided dy by dx is equal to slope. Then after again integrating that, then EI y is equal to deflection. Then in one word they might also ask the boundary conditions for simply supported beam and cantilever beam. So we have to learn this also. It's nothing but for simply supported beam, x is equal to 0. When x is equal to 0, x is equal to L. For y is equal to 0, the same y is equal to 0. For cantilever, same thing, x is equal to 0, x is equal to here 0. Then deflection, y is equal to 0, y is equal to maximum deflection. They might ask you these questions in one word. Next thing, 1 minute. Yes, here. Okay. The difference, what are the difference between a simply supported beam to find the slope and the deflection using the double integration method and the Macula's method? The difference between the cantilever beam and the simply supported beam. Okay, for simply supported beam, we have already told that there is no moment, but we have the reaction. We in cantilever beam, no need to find the reaction. Okay, here the moment is 0. Here the moment is maximum at the fixed end, not at the free end. At the fixed end, the moment is maximum. Okay, the next thing is when the load is applied, already I told that when the load is applied, the beam tends to deform. Okay, I have shown you. I have shown you here. Here, here, the beam tends to deform. So the distance between the original position and the deformed position it's to find the deflection. Okay, so it is given here. Then the slope starts from the middle at the end of the free end. Then here slope is 0. In cantilever, slope is 0. Then the tangent line is drawn from the actual line called slope. It is drawn from here. This part, can you everyone able to follow my cursor here? Then whereas the moment is 0 at the free end, I told that moment is 0 at the free end, moment is maximum at the fixed end. Then these are the procedures and boundary conditions we have seen there. X is equal to 0, X is equal to L, Y is equal to 0, Y is equal to 0, then X is equal to L, X is equal to L, Y is equal to 0, dy by dx is equal to 0. The moment deflection slope, in case they ask you to find using a double integration method, you have to find the moment, sorry, the deflection. Using double integration method, you have to find the slope. In that case, I will show you an example here. Here is in here it is given as a cantilever beam carries uniformly distributed load of the overall load. They have given here two loads. One is point load and a UDL load. And point load is at the free end. We have to find the slope and the deflection. Then I have already told you that if one load is there, we have to use the Maclaurin's method, and two more than one load is double integration method. So in that case, the deflection of the point load is at the free end. The UDL load is also given. Then we have to find assume section of the beam is circular with dimension of 450 mm and modulus of elasticity. That is E value they have given 2 × 10⁵ Newton per mm square. We have to find the moment with the help of the boundary conditions. We have to find the values. Then again we have to integrate, double integration. We have to integrate. Then at the free, we have to find the deflection at the free end. Then slope at the free end with the help of the formula. Then with the finally we have to find the EI, the value of EI. Okay. Have a glance to this. It's a very simple question. First we have to find the moment. Since it I mean, why we are finding moment, you can ask a question like simply supported beam, we have to find the reaction, and then we have to find the moment. Here we know that there is no need of reaction because it is a cantilever beam, but you have to find the moment here for this section. Then I have to integrate. We know how to find the moment. We have seen in the last class. Then we have to integrate. We have to find the moment, then deflection, then slope. Okay. Then after that, with the help of the boundary conditions, we have to find the values. Then after that, we have to find the deflection. Since it is a cantilever beam, so we have to find the load is at the end. So we have to find the deflection at the free end. Then the slope at the free end. Both the deflection and the slope at the free end only. Then to finally we have to find the value of E. Finally, we have to find the value of EI. Same case, if it is a simply supported beam, in case there is a slight change, we have to find the reaction. Am I going fast? Anyone? Okay. These are the important terms in deflection of beams. You have to know the difference between the Maclaurin's method and the double integration method. In which case we have to use the Maclaurin's method, in which case you have to use the double integration method, and you have to know all these formulas, because in one verse they will ask, because how will you find the deflection for central when a point load is acted at the, in case of a simply supported beam, when there is a point load is applied, find the deflection. They might give the values of W, E, L. They might give the values of L, W. All these we have to find any one of the values in this. In that same, as well as they might also give for cantilever beam also. So you have to know the formula. For simply supported beam, only 4 formulas. For cantilever beam, in case if the load is acting at the free end, what is the formula for deflection and slope? In case the load is acting at the center, you have to know the formula for the slope and the deflection. The question will be simple as like this only. Okay. The right hand side on image is there, no, right there. Next. Okay. Next lesson. Columns and struts. We all know that. What is a column? it is a compression member and it is also vertical member. We all know that. Beam is an horizontal member, okay, and it's also flexural member. I told what the reason for why we are calling the beam is a flexural member in the last class. But here it's a compression member. Why we are calling a column as a compression member? It's nothing but a column is used in between the to carry the load. Okay, when the load is supplied here, this is a column, right? This is a beam. There is a load. There is a load here. It bears the whole load. There is a column here also. There is a load here. Sorry, if there is a load here, it bears the load, the total load. Okay, if it is a point load, it's a UDL load, but the column bears the load, so it's compressing it. So it is called compression. Then what is a strut there? It is a slender member, nothing but it's a slender member. Here it is here it is slightly positioned other than the vertical. Here this is a column, this is a beam, and this is a strut. Okay, wow. When the load is here, this is a cantilever. This image is a cantilever view. Okay. Okay. Now, how there is a columns is also two types. Short columns and long columns. How will you find it is a short column and how will you find it is a long column? In that case, how will you find? Abdin Keta, what in case you will have a doubt, how will you find a short column and a long column? In that case, what you will do? To keep in mind, 1 minute. Okay. To keep in mind, it is useful here. Slenderness ratio. They will say it's nothing but effective length. It is a ratio between the effective length to the least column dimension. That is LLD, least column dimension. If it is greater than 12, then it is a long column. If it is lesser than 12, then it is a short column. Here, least effective length. Okay, the length is effective. You find the formula. Then what is the least column dimension? It is nothing but in case if it is a here it is. Here, see this picture. In case, see here, this is a here it is given a radial, a circular column. Okay, circular column. This is a section. This is the overall plan of the circular column, and here, the okay, sorry, 1 minute. Here it is in case of a rectangular column. This is the plan of the rectangular column. The LLD, the value least. 1 minute. Least column dimension. The value of a least column, that is this dimension. We have to consider this dimension, and L is the effective length. Effective length varies according to the the end conditions. Okay, we will see. But what is least column dimension? In the if it is a rectangular or a square, then this side, the length of this. Okay, we have to calculate that. If it is more than 12, let this slenderness ratio is more than 12, then it is a long column. If it is less than 12, then it is a short column. The difference between the long column and a short column. What is the major difference between the long column and the short column? In case of a short column, I already told you that it is less than 12. It is less than 12, and then it is faced with crushing. And long column it faced with buckling. In that case, you will have a doubt. What is buckling and what is crushing? Okay, I will say you. Then it's subject to the compressive stress. We know it is subject to the buckling stress. And radius of gyration is more, radius of gyration is less. More load capacity in case of short column. Everyone will have everyone will have an idea that if it is a long column, then it must carry the load capacity more. Okay, but in this case, the short column carries more capacity. What's the reason? So we will see further. Okay, first the word term radius of gyration. The best example is nothing but the giant wheel. It's given here the giant wheel. It's really a simple thing. The radial distance between the center, here is a point, right? This point. The radius is at this point would have the moment of inertia, the same as the actual body's distribution of mass. The total mass of the body was concentrated. Nothing but the radial the load here, the moment of inertia is same as the load concentrate in the center. Here it is concentrated. It's concentrated in the center. The center level that is load is spreading and the load போகுது. So in that case, it is a radial axis. Nothing but is radial axis having the moment of inertia centerல இருந்து அந்த end வரைக்கும் having the moment of inertia as the body's actual mass distribution of actual distribution of mass. If the total mass of the body were concentrated, இப்போ மொத்த body mass ஓட பாடியோட மாஸ் இங்க சென்டர்ல வந்து கான்சென்ட்ரேட் ஆயிருக்கும் போது is the same as a moment of inertia from the center to the end. Okay, wow. That is called as radius of gyration. Then what is buckling? Okay, buckling. The next time, what is buckling? Here it is what is buckling. Buckling of columns. It is nothing but it is a column. There is a circular column or it is a square column. It is a rectangular column, whatever it is, geometrical column. If it is a column here, when the load is applied at the center, axial load that is concentrated at the center point. இப்போ in case இப்போ அந்த லோ ஐ மீன் அந்த லென்த்தை விட வந்து இந்த லோடு வந்து அதிகமா இருந்துச்சு அப்படின்னா that is the case of buckling. ஓகேவா? இப்போ buckle ஆகும்போது it is buckled like this, either in rightward in the direction of rightwards or towards the leftward, ஏதாவது ஒரு direction வந்து buckle ஆயிடும். So in that case, even if it is a rectangular column, the same thing will happen. ஓகேவா? It is called as a buckling or crippling of columns. Okay, it is called as buckling or crippling of columns. And to find it, so we have to buckle ஆகுற அளவுக்கு we should not leave to find if it is and the buckling இல்ல crushing அதெல்லாம் நடந்துச்சு அப்படின்னா, in case if it happened அப்படின்னா it is a failure. Okay, you know that it's a failure. To avoid that, PI safe is we have to the load what we are going to apply நம்ம என்ன load apply பண்ண போறோமோ we have to be clear. And the load வந்து அந்த column வந்து the load தாங்குமா அப்படின்ற ஒரு we have to have an idea. For that we have to know this formula. Keep in mind PA that is load is PA safe is equal to buckling load divided by factor of safety. Buckling load divided by factor of safety. To know what load we are going to apply to omit buckling, we have to know this formula. PA safe is equal to buckling load divided by factor of safety. Okay, wow. So how will we find the buckling load? In that case, what we will do? அப்படின்னு கேட்டோம் அப்படின்னா buckling load எப்படி கண்டுபிடிப்போம்? How will you find அப்படின்னு கேட்டோம்னா it varies for the long column as well as the short column. Okay, wow. For long column we have a separate method and for short column we have another method. Okay, in case of a long column we will find the Euler's method. In case of a short column we find the Rankine's method. The Euler's method is preferred only for long column and Rankine's method is only preferred for the short column. Okay, wow. So buckling load ஓட ஃபார்முலா வந்து Euler's method prefers long column to find the buckling load. Then Rankine's method prefers short column to find the to find the buckling load. Okay, so in that case I have already told that you have how to find the long column as well as a short column. It is nothing but the effective length divided by the least dimension column, which lateral dimension. It is if it is greater or if it is lesser than 12, we have to know which is long column, which is short column. In that case, before that we have to know the in that case for long columns Euler's method is preferred and for short column Rankine's method is preferred. So the first formula is nothing but PA safety is equal to buckling load divided by factor of safety. Then long column, then Euler's method buckling formula divided by factor of safety. For short column Rankine's method formula divided by factor of safety. Okay. Okay. Here okay. Here then in case I have told about buckling and crushing, right? What is buckling? I have told you. What is crushing? Here also same case, nothing but when the load is applied here, it starts to buckle. That is, it deforms the original position. Okay. In case it crushes like this at this state, it crushes. It happens in not only it happens in short column and the buckling happens in the long column. Okay, and they will ask the question like they might also ask the question like this: what columns? Okay, Euler's method prefers what type of column? Long column. Then Rankine's method prefers what type of column? You must know short column. Don't get confused. Have any one in your mind? Then the formula PI is equal to say buckling load divided by factor of safety. Don't forget this. Okay, then Euler's method. The simple equation for Euler's method, Euler's theory. We have to keep this in mind. This equation or for Euler's theory. Guys, we have to keep lots of formula in your mind. Don't forget. In case if you don't know, you have to derive. I will give you the derivations. You just have a glance to it. Here, Euler's method. Now, PC, that is crippling. We have told that Euler's method is nothing but it is used for a long column. In long column, buckling happens, not pressing, buckling happens. So in that case, we have to use this equation. PCR is equal to pi 2 into EI divided by L square. Okay, wow. PCR is equal to, again I'm saying PCR is equal to, that is load crippling is equal to, root crippling or buckling is equal to pi 2 EI divided by L square. Okay, wow. Then assumptions followed in Euler's equations. Nothing but homogeneous or isotropic. You have a glance into this all these sentences. Homogeneous or isotropic and elastic, and the section of the column is uniform throughout the section of the column. When we take a section, when it is buckled, when we take a section, it is uniform throughout the column. Then only axial load, that is straight. I have shown you here. Here only axial load at the center in case of a long column. Then the limitations of the Euler's, then the column phase buckling method we know. The effect of the direct axial stress is neglected here. And the next is limitations. What are the limitations for this formula? It is not valid for mild steel. I have told that for a steel, the value of E is the value for modulus of elasticity is equal to 2 into 10 to the power 5 Newton per mm square. In that case, if it is a mild steel, it is not valid. Then slenderness ratio of the mild steel is less than 80. For mild steel, it is less than 80. Then does not take the as I told, it does not take the direct stress. But in excess of load, it can withstand under direct compression only. Keep in mind, இது வந்து என்ன ஆகாது அப்படின்னா direct stress வந்து எடுக்காது. But in case if it is an axial load, எவ்வளவு load கொடுத்தாலும் அது வந்து buckled ஆகி it can withstand, because here under it is a compression. It takes here compression. So buckle ஆகி நிற்கும். In case of direct stress எடுக்காது, but load எடுக்கும். ஓகேவா? Next. இதுதான் சொல்ல வந்தேன். I told you right, that I mean the load form, the buckling load formula varies according to the different end condition for the long columns. In that case, we saw the different end conditions. Both ends are hinged and both ends are fixed. One end is fixed and other end is hinged. Then one end is fixed and other end is free. In that case, what is that? First thing, keep in mind, both ends are hinged, both ends are fixed. Here I will show you. Here, okay. Here is also nothing but it is the same formula. Both ends are hinged, both ends are fixed. What in case both ends are hinged? Here, load is equal to pi squared. I have already told you the Euler's formula for crippling. Pi into pi square into EI divided by L square, right? Here, for in case if it is hinged, the same thing, pi square into EI divided by L square. But in case, before, we have to have an idea that for L, we should not substitute the direct length. For that, we have to have, for both the hinged means, for L means if it is an effective length, okay, it is not the direct length, it is an effective length here. Notice here, it is an effective length here. So effective length is equal to the normal length. So load is equal to pi square into EI divided by L square. In that case, here the value of L is the effective length. In case of both end hinged, the same thing. If the L is here 3 meter means it's 3 meter. 4 meter means 4 meter. In case of only both end hinged, they will ask the question, how will you find the length for the both end hinged? So you must be ready. Here itself we can ask 3 or 4 more questions here in this single thing, both end hinged. What is mean by both end hinged? We must have the, and that case you should able to remember this diagram. Both the ends are hinged, and how will you for L enna value substitute பண்ணோம் அப்படின்னா, in case that not the normal length, in that case we have to find the effective length. Then next thing is both end வந்து fixed அப்படின்னா அதுக்கு என்ன formula? That is nothing but 4 pi square ei divided by l square. Here it is nothing, pi square, the same Euler's formula, pi squared into ei divided by l squared. Here it is load is equal to 4 into pi squared ei divided by l squared. Nothing, simple thing. In that case, if effective length பதிலா நம்ம normal length divided by 2, effective length l இருக்க இடத்துல normal length divided by 2, it varies, so keep in mind, don't forget. Then if in case of one end hinged and other end, one end fixed and other end is hinged, in that case what you will do? Okay, in that case here it is also l is equal to 0.5 into l, that is 1 by 2 is equal to 0.5, right? So l is equal to 0.5 into l. You can also find that the same answer. And in the here also you can find the l is equal to 0.070 into l, then 1 by root 2, the value is 0.070. Okay, in that case one end is fixed and other end is in that case how will you find? So load is equal to 2 pi square into ei divided by l square. Keep in mind, don't forget, you have to memorize these formulas. They will ask the question, what is the diagram for both end hinged, and then what it is valid for effective, what is how will you find the effective length for in case of both end hinged, both one end is fixed or one end is hinged. So you have to know. Here it is 2 pi squared into ei divided by l squared, and one end fixed and other end free. In that case, what is the formula? In that case, l is equal to effective length is equal to 2 into l. P is equal to pi square ei divided by 4l square. Okay, wow. Don't forget this tabular column, and for third lesson I have shown you the one page, right? That is very much important, so don't forget. The next thing, a simply for this is a small example for this. A simply supported beam of length 3 meter is subjected to point load. Okay, nothing but a simply supported beam here. A simply supported beam, you know, simply supported beam. What is simply supported beam? Both the sides there is a support. Okay, simply supported beam 3 meter length. Okay, subjected to the load. Okay, 3 meter full subjected to the load. The beam used as a column. Here the beam used as a column. Determine the crippling load of the column when both ends are hinged. The size of the column. If it is a column, right? In the column, I mean other section. Okay, I mean other plan. In the square and the column which go. The column abina, then 320 cross 260 mm. You know the value for steel, that it is 2.2 into 10 to the power 5 Newton per mm square. So in that case, they have given the clue that both the ends are hinged. In case of both the ends are hinged, how will you find? If it is a cantilever beam, if it is a simply supported beam, the same formula must be used. There is no change in that. So don't forget. But only the variations in end conditions. It varies only with the end conditions. Both ends are hinged and both ends are fixed. One end is fixed and other end is hinged. One end is fixed and other end is free. In that case, here it is given almost that is both the ends are hinged, and in that case they have given the they have given the the length, the length into breadth, that also 320 mm into 260 mm. And we all know that modulus of velocity, the value of V for steel. Okay, and the next thing is whatever is given here, crippling load. You know the formula. Load is equal to pi square into ei divided by l square. So in case of hinged load, in case of hinged in the if it is a condition like both ends are hinged, then this is divided by l square. Then effective length is equal to the normal l square. Okay, l square. Yeah, here l is value is 3. The same l value you are going to substitute. Then the pi value. Before that, for finding I, if it is a circular section, you have the moment of inertia, you have one formula. If it is a rectangular section, you should know one formula. If it is I section, you should know one formula. So in that case, you know what is moment of inertia for rectangular section, VDQ divided by 12. Upload of I section in as. In case of that, you have to know the formula. So what is the value of B? 320 into depth, 260 cube divided by 12. Okay. So moment of inertia formula is here. Then after that, P is equal to pi squared into EI divided by L squared. We have to substitute all these value. You know the E value, you know the I value, you know the L square value. So you have to find the load here. Load, since it is a load and Newton or kilonewton. Okay. But here it is only Newton. In the formula is only Newton. So you have to be very careful with the units also. In case they ask the formula, in case it asks for the cantilever beam, if it's one end is fixed and other end is free, what is the formula? How will you find? In that case also you must be able to find. If it is, they will give the dimensions for if it is a rectangular column or linear column, they will give the size of the help of the diagram. Or else they will give the remaining details and you have to find the size of the column. Or else they give the remaining all the details, you have to find the length. This effective length or normal. Sorry, effective, you have to find the effective length in that case. So don't forget, keep this page in your mind. Guys, am I going fast? Okay, I looked it. Okay. Yes, these are things we have to find. Then rankings method. I told you that for long column, there are some in conditions in case of failure. So to அந்த failure நடக்காம இருக்க, we have to find the load, perfect load. என்ன load apply பண்ணணும், we have to find the load. In case of it is a short column, we have to use the crushing happens. So Rankins formula prefers short column and long column prefers the Euler's method. Now load is equal to sigma C into A. This is Rankins formula form. Rankins methods formula. Load is equal to sigma C into A. A is nothing but the area of the given column. If it is a radial column, circular column, or if it is a rectangular column, you have to know. Then divided by 1 plus A into L, that is effective length, divided by K in K the whole square. Okay. Now here it is, we have to know the full form for that is P is equal to crippling load, sigma C is equal to crushing stress. I have already told you that you should know the difference between the long column and the short column. In case of a long column, that happens a buckling. In case of a short column, it happens a crushing. But in short column, it bears more load, but in long column, it shares the load capacity is less. When we compare to the short column, the load capacity in long column is less. Okay, well, for that we have find several edge conditions in case of the failure. For the 4 types of edge conditions, with that you have to find the how which load is up, which I mean எவ்வளவு load கொடுத்தா அது வந்து applicable சொல்லி we have to find. Then in this case crushing area, we have to find the norm. If it is a rectangular form, what is the area? Then K is nothing but the radius of gyration, we all know. To find K, what is the formula? The root of 5 by moment of inertia divided by A. Then L is equal to effective length. Then alpha or A is nothing but Rankine's constant. Okay, wow. Rankine's constant, how will you find the Rankine's constant? It varies according to the material. For the forthcoming thing, it varies according to the material. So you have to also keep this formula in mind. Don't get scared. Third, fourth unit is very important. We have to know the formula. Formula தெரிஞ்சா மட்டும் தான் you have to you will able to attend the questions. Okay. Both here Rankine's method. If it is a raw, they will give the question as if it is raw tire, if it is a cast iron, or it is a mild steel with timber. Only these two materials they will give. In that case, how will you, what is the Rankine's method constants value, and what is sigma C's value? Sigma C is nothing but crushing stress, and what is the crushing stress value? With the help of that, you have to substitute all these values and you have to find the Rankine's. I will show the example at the last. Okay. So don't forget, for Rankine's formula, there is a short column, there is a long column. We know how to find the difference between short column and the long column. How to find this is a long column and short column. In case of a long column, only Euler's method is applicable. In case of a short column, Rankine's method is applicable. In case of a long column, buckling, there is a failure called as buckling. Here is a failure called as crushing. In case of buckling, there are 4 types of edge conditions. Here it is. We have to know the formula. Then should not substitute the length value as it is. In case of inch, there is a length. There is a formula for length, and in case of fixed, there is a formula for length. And in case of one end is fixed and other end is in, there is a formula. One end is fixed and other end is free. There is a formula. Okay. Both the core simply supported as well as the cantilever beam. Uh, yes. Shall we have a break after 15 minutes? Shall we see the remaining? I will show some examples for this Rankine's method, Euler's method. I will show some examples. For 10 minutes, we can have a break. Sharp at 11 o'clock, we can come back. Is this okay? Welcome back, people. Okay. Shall we start? Or I have to wait for 5 more minutes? Anyone? Am I audible? Guys, please message in the chat, at least in the chat box. Anyone? Shruti, Suresh? Audible? Okay, now it's clear. Shruti, now am I audible? Okay, we can continue. Okay. Before the break, we were talking about Rankine's formula. In which case we must use Rankine's formula, and which case we must use Euler's formula. We had a clear vision. Small example for this Rankine's formula. One minute, guys. Mm. Here it is. Okay. I told you that it might not be only a rectangular column or a square column, but it's also a circular column. Okay. For this using Rankine's formula, we will use this Rankine's formula method in case of it is a shorter column, and also if it is in case of a shorter column, in case of in case of a short column, the failure happens through crushing. Okay. For the simple example for this, hollow cast iron column, 400 mm outside diameter and 350 mm inner diameter. Always you know that the hollow cast iron column, you know how the hollow shape it is. So that is the variation in the outer diameter as well as the inner diameter, right? So outer diameter is 400 mm and inner diameter is 350 mm, right? And 5 meter long. The length of the column is 5 meter long. It's nothing but length is long. Then it has both the ends are fixed. Here there is no need. Given the conditions, but there is no purpose. Only one formula we are going to use. Only in the case of long column in the Euler's method, based upon the end conditions, the formula varies. Here only for short column in case of crushing, only one formula is there. So you have to use this formula. So determine the safe load as a for determining the safe load as per Rankine's formula they have given there. Assuming factor of safety, I have already told you that for Rankine's formula, at the last page we have seen that in this case, right? If it is a wrought iron, and what is the value for the crushing stress, and if it is a cast iron, if it is a mine steel, or if it is timber, what are the values for crushing stress, and as well as the Rankine's constant. But here the given, in some cases they will give the before in the question itself they will give you the values for crushing stress as well as the Rankine's constant. In that case they may give the all the details in this. They will ask you to find the what is the area in case of it is a hollow cast iron. You must know the moment of inertia for a hollow cast iron, for rectangular, for a circular section, for a rectangular, for a square. You must know the moment of inertia. So in that case you must be very clear. Okay. For that case, here it is a hollow cast, nothing but it is not a rectangular column, or it is not a square column, it is a hollow cast iron column in that case. So it varies, right? First of all, crushing stress formula, they have crushing stress value they have given it as a 550. You have know that what is the area of that? For that case, we have to find the area of a circular column. Then divided by 1 plus A you know the Rankine's constant's value is given with 1 by 1000, 1600. Okay, they in case they might give it is a wrought ion. They might in the question simply it is a wrought ion. It is a mild steel. And in that case, you must know the Rankine's constant as well as the crushing stress. Okay, here they have already given the Rankine's constant as well as the crushing stress, so there is no need of finding. So in that case, first of all, we have to know. First, we can start with K. K is nothing but radius of gyration. I have already told the best example for radius of gyration is giant wheel. So K is equal to root of I divided by A. I is nothing but moment of inertia for the hollow. Remember, it is not a rectangular; it is a hollow cast iron. For hollow cast iron, it is and there is also a diameter for the inner one and as well as the outer circle, right? So in that case, pi by 4 divided pi by 64 divided into d power 4 divided minus d power 4. You have learned this already. Okay, the area is nothing but the area of that is pi by 4 into d square minus d square. So to find the moment of inertia, we must know the I mean I is equal to for the column, I mean for the whole Castrian as well as the inner circle moment of moment of inertia. For that, you will, after solving that, you will find the I value here. Okay, then after that, with the help of the area, the K is equal to the I value divided by area, we will find the radius of gyration. And after simple formula, that is crushing stress, area, Rankine's constant, then radius of gyration formula. With the help of this, we will find the same. We will find the so that is the crushing load. It is not that's not a tripling load; it's a crushing load. In case it is because it is a Rankine's formula, short column, it is a crushing load. So after that, we have to find the safe load. Already before we are starting the lesson, I have told a formula for the safe to find the why we are finding. So in that case, if it is a long column, we have to find the buckling load or tripling load divided by say factor of safety. If it is a short column, crushing load divided by factor of safety. So crushing load we have found that and divided by factor of safety is 6. So we have given the safety as the 6 Rankine's method. So you have to read the question twice. Don't forget. So in that case, factor of safety is 6. So divided by the unit is same, Newton. Okay. This is a small example for this. Don't forget, guys. We have only two columns, not more than that. Short column and long column. In which case you use which formula? In the only for long column you have the end conditions. In case of a failure, there is buckling or crippling. In case of short column, there is no failure. So this is crushing method, and that's it. For short column, I have to use this. This method. For long column, I have to use this buckling, crushing. I have told you. Keep for radius crushing. Keep in mind the giant will. And with the help of the centerness ratio, you will find the long column and short column. Okay, am I clear? We have finished almost 4 units. The last one, unit 5. Okay, actually when we are talking about determinate structures, we have already seen in and I think first lesson what are determinate structures. Here it is, right? What we know, what are beams? Beam is a flexural member, nothing but it's a flexural member. And we have seen the types of beam. We know cantilever beam and beam, simply supported and beam, overhanging and beam. We know all the rules. And in that case, we have considered this, if it solves the equilibrium equation, nothing but summation of m is equal to 0, horizontal and vertical is equal to 0. If it solves these equations, equilibrium is called as equilibrium equations, right? If it solves these equations, then it is determinate structure. We have seen that it is determinate structure. For example, cantilever beam, simply supported beam, and as well as the overhanging beam, right? In that here, it is statically indeterminate structure. Then what is indeterminate structure? First of all, before getting into that, we must know what is the structure. What is that? It is the combination of both the frames, beams, columns, all together is forms a structure, right? In that, slabs are used to resist the external load. We know what is the what the wall role that the slab plays there. Okay. Now, when we get into the structure, we should also know the basic. We should have the basic thing about what the structure is. Frame structure, mass structure, surface structure. We also know the VC structures. Okay. In the case of frame structure, this is nothing but a simple, usual buildings, your home or whatever it is, normal buildings. It can transfer load continuously. Like room column, that is one column, room to column which one. Up on the அடுத்த ரூமுக்கு அடுத்த column, so it continuously transfers the load. And okay, in that case it is a frame structure. What is a mass structure? Always say mass structure. Mass structure is nothing but a total, this is all the structure. மொத்த area, solid area to be a load, it is also called as a load bearing structure. Okay, wow. The next thing is, what is a surface structure? Only on the surface. For very example, for the surface structure is nothing but an umbrella. See, umbrella heel and stick, it's a linear thing, and the surface carries the total load, in which the load, in which part the load, sorry, in which the part which the load is actually transmitted on the whole, it's on its surface, so it is called as a surface structure. Okay, so you know the difference between the mass structure, frame structure, and surface structure. Then next, we are getting into the statically indeterminate structures. Then what is statically? We know that determinate structures. What is determinate structures? Nothing but it, using the equilibrium condition. It is determined by the equilibrium conditions. Okay, to solve the equilibrium conditions. So in that case, we have seen some examples in what is the equilibrium equations. What are the equilibrium equations? We know summation of m is equal to 0, summation of s is equal to 0, summation of b is equal to 0. In that case, for some examples, cantilever beam, simply supported beam, overhanging beam. We have three beams, right? For determinate structure. In case of indeterminate structure, what is the indeterminate structures? If determinate structures determines the cantilever equilibrium equations, it is the opposite to that. Okay, statically indeterminate structure is nothing but it does not obey the equilibrium equations. In case of that, we have some examples like continuous beam, fixed beam, 2-hinge arc, propped cantilever. The other through hinge arc, you have an idea. You have an idea about what is continuous beam, what is fixed beam, but you don't know what is a cantilever propped beam, propped cantilever. Okay, in that case, what is a propped cantilever? You have a question for that. It is nothing but here it's a simple diagram. It is also similar to a cantilever. It is almost given that the keyword is given that a propped cantilever. It's not given a propped beam. It's formed cantilever beam. So it is fixed here. In case the load is acting here and it started to, if it is its original, it started to deform position like this. Okay, in that case, if you have to give the load from the downwards, okay, that is up. You have to from the down to the up. You have to give the that load is called as propped. That is called as propped cantilever beam. Okay, wow. Before certain stage, I mean cantilever beam, if it is the length of the beam, that is in this section, the length of the beam is when we apply load at the free end, we know that at the free end moment is 0, and at the fixed end moment is maximum. And free end is, if it is started to deform from its original position, in that case we have to apply. We have to give a support down. That support middle, one in the middle. Okay, both the side we have picking the load, picking the support like this. It is the prop. That's first we have statically in the what are the statically indeterminate structures and what are the determinate structures and how we define the statically indeterminate structures and degree of indeterminacy. What is degree of indeterminacy? It is also raised as 2. Okay, இப்போ static indeterminacy and kinetic indeterminacy. I think the static indeterminacy and kinetic indeterminacy. இப்போ static, what is static indeterminacy? You have a question, right? Number of unknowns available on the structure here. 1 minute. Okay, number of unknowns. 1 minute, guys. Sorry. Number of unknowns available on the structure before applying the load. For example, the unknowns na, I think unknowns na, unknown forces. Okay, sorry, I have not written there. Unknown forces, unknown number of unknown forces available on the structure before applying the load. Load apply we will have an idea here. Still, we have learned that when we applied only when we apply a load, there is a change in the structure, there is a deformation and etc. All those stuff. Okay, but in this case, before applying load, what are the forces and what are the unknown forces available in the structure? We must have a clear vision on that. Okay, in that case, what are the, if number of unknown forces available on the structure before applying the load, abdina, it is a static indeterminacy. But after applying the, always kinetic means it is a movement. Okay, always, you have an idea of kinetic energy, you will learn before, right? So it's movement. Static is a stable position. Okay, so before, after applying unknown forces, what it is not kinetic indeterminacy. Before not static indeterminacy. See, might be the question might be asked. So Listen carefully. Number of unknowns before applying load. Number of unknown forces after applying the load. Okay, wow. The next thing. Methods of analyzing indeterminate structures. Methods of analyzing indeterminate structures. There are several methods. One or two you can keep in mind. They might ask, find the odd one. In that case, you must be able to find. Okay. In that case, strain energy method, slip deflection. You know what is slip deflection method? Moment distribution method. Column analogy method. Column analogy method is nothing but last time we seen that short column, long column method. Then virtual work method, matrix method. Okay, wow. In the matrix method, we have two different methods: flexibility matrix method, stiffness matrix method. Flexibility matrix method is nothing but okay, flexibility matrix method and stiffness matrix method. First, we know the methods of analyzing independent structures. What are the methods? We should have a clear idea because they might ask the question. Find the odd one. Okay, they will find for finding the analyzing indeterminate structures. What are the methods? And for finding determinate structures, we will have some methods, right? We have seen in last class for first unit. So finding indeterminate structures, if they asked you the question, find the odd one, you must be able to know. In that case, we have to know all these methods. Okay, wow. Okay, now support of okay flexibility matrix method. The next thing, types of support. I have told you that before the thing we will always have that 1 minute guys. Okay, before types of support with static indeterminacy. I have told you that before applying a load, there will be a number of unknown forces is applicable there. Now we are seeing the static indeterminacy in the statement. We are placing the about static indeterminacy. In that case, only three things, nothing but only three things: fixed, hinged, roller. Fixed, hinged, roller. If it is a fixed, there are three reactions. If it is a hinged, there are two reactions happens. Fixed, I have already told you that at the fixed end, the moment is maximum. So it is a three reactions. And here it is, if it is a hinge, see the diagram, because in this chapter only small problems will be there, so it will be asked in your MCQ questions, no doubt in that. So fixed na about three reactions, hinge na there is two reactions, roller na there is a one reactions. Okay, ba fixed na continuously three reactions, hinge na the diagram will be like this, then roller na the diagram will be like this. Keep in mind, don't forget this tabular column is very much important, so don't forget. Okay, this is the last one. Nothing serious. Okay, now degree of the static indeterminacy. How will you determine the degree of that static indeterminacy? It's nothing but internal and external. Nothing but internal and external. I have already told you that last page we have seen the types of support. So internal means it determines only, can be determined only by the support. If it is an external, determined only by the member. For that we have going to see some examples here, and we have to know the values. We have to know this formula. Don't forget. In case of the static indeterminacy for beam, frame, there's only three things. Nothing but beam, frame, and truss. In case of an external as well as an internal, in case of external, what is the formula? In case of an internal, what is the formula? You have to know that. So beam R is R minus 3 for external, and for all the external to find the external nothing but a member. To find that, the formula is nothing but R minus 3. That is, I will say, how will you find the R? Okay, right side I have an example for that. I will say this. For internal, for beam it is 0, and for frame 3 into C. Okay, wow. 3 into C. I will say the value for the, how will you find the C also. In case of a truss வந்து அவ்வளவா கேட்க மாட்டாங்க, but in case of the formula they might ask. Okay, wow. The most important thing is beam and frame. Okay, wow. In that case, the best example for beam and frame. Okay, here I have already told you that this diagram represents nothing but previous page we have seen. It is hinged. If it is a roller, it will be like this. If it is hinged, it will be like this. If it is fixed, the diagram will be like this. In case of fixed, 3 reactions. In case of hinge, 2 reactions. And in case of roller, 1 reaction will happen there. So in that case, if it, we have already have we have known that it is hinged at the end, and these two are nothing. This fixed at the end, and these two are hinged. In case of fixed, I have already told you that three reactions will happen. Okay va? Three reactions நம்ம எதை மீன் பண்றோம் அப்படின்னா nothing but, see here, if it is three reactions, one is moment, that is one reaction, one is horizontal reaction and one is vertical reaction. So here it happens three reactions. In case of hinged, there is no movement, only upward reaction and downward reaction. Okay va? In case of roller, there is only one reaction, either right hand side or left hand side, it moves, right? So that determines reactions. If you're getting confused at this stage on which for which support which reaction, you have a clear idea on this. If it is a fixed state, there's three reactions, one is movement, horizontal and vertical, as well as a hinged, only vertical and horizontal. In case of roller, only either horizontal, either right hand side or left hand side. Okay va? So in that case, nothing but external. R minus 3. We for beam here, by seeing this, you will have an idea that is a cantilever. So for find the external thing, R minus 3, you know the formula. For it's fixed, so that happens reaction. So 3 plus, and here it is hinged. So here it happens upper reaction. So it is 2. Here is also hinged. So we 2 reactions, down vertical reaction and horizontal reaction. In that case, 7 minus 3. Okay, wow. 3 plus 2 plus 2. So 7 minus 3. The R, we have to find the R value like this, nothing but it is a fixed, it is here, it is hinged, here it is hinged for fixed three reactions. What are the three reactions? One is moment, other one is vertical, other one is horizontal. Here is for a hinged, horizontal and vertical, that's it. So 3 plus 2 plus 2, that is equal to 7, 7 minus 3. In case of internal, there is no, what I told you, that external is a member and internal is a support. Here there is no support here, only it is, there is an external member is given here. So in that case, we have to use this formula. Okay va? The next thing, okay, the next is the same thing, it is also the beam. Third one is frame, second one is also beam. The nothing but here is they might also ask you, they might also confuse you. Okay, if இங்க வந்து நம்ம cantilever சொல்லிட்டோம், so we have been using this அப்படினா we have to, so I already told you that you have to have a clear vision about the diagram. How இப்போ வந்து hinged na எப்படி இருக்கும், frame na how it will be, how the truss na how it will be. So you have roller support na எப்படி இருக்கும், hinged na எப்படி இருக்கும், fixed na எப்படி இருக்கும், you have to have an idea. So in that case, here here is, you know that it is fixed. By seeing the diagram, you can able to see that it is a fixed, and here it is a hinged. Okay, but I have already told you fixed only 3 reactions and then hinged only 2 reactions. So 5 minus 3. So here 3. Okay, here is also internal is 0. It is, since it is a beam, so and there is no support is this. Here is a only external member. So we have to use this formula and we have to find. Okay, next frame. How will you find this a frame? The simple very example is a closed loops. C is nothing but a closed loop. We have to find that closed loop. C is nothing but a closed loop. Here is also the same thing. Here is also given, the fixed is also given, the hinged is also given, and the road. 3 types of supports are used here. Okay, va? 3 types of supports are used here, and the member is the closed. That is, the structure is here closed, right? So closed loop. So in that case, we have to find the both. You have to, you know, by seeing this, that you can have you will have an idea. It's a frame structure. Okay, va? Because that is a closed loop, and for finding that, external is equal to r minus 3. 1 minute guys. External is equal to r minus 3. Internal is equal to 3 into c. C is nothing but closed loop. How many closed loops are there? 2 closed loops. By seeing the diagram itself, we can see the intersection. 2 closed loops are there. So r minus 3. R value is nothing but here it 3 for in a case of fixed support 3 reaction happens. In case of hinged 2 reaction happens. In case of roller only 1 reaction happens. Now 1 reaction in case of, and also you may get a question like this. Okay, in case of roller we are saying that there is only 1 reaction. What is that reaction? Either right hand side, because it's rolling, right? Either right hand side or left hand side. This is horizontal reaction, not a vertical reaction. It is just an horizontal reaction. Okay, so external 6 minus 3. Okay, here it is 3, here it is 2, and it is 1. So 6 minus 3. So here is 2 types of ruler. That is 2 loops are there. So 3 into 2. That's it. This is 5th lesson. Nothing but they will you will get a question only like this. Very simple questions. Both the 5th lesson, 3rd lesson, and 4th lesson, and also the first 2 lessons. For first 2, I mean for a 3rd, 4th, and 5th, you have to memorize the formulas at certain stages. So we have to we have to have a clear vision about the formula. First, we have seen the deflection of beams. The deflection of beams nothing but if it is a cantilever beam or if it is a simply supported beam. In case of a central point load, in case of a UDL, what formula we have to use, you have to have a clear vision on that. You have to know the moment of for you will learn already have learned in MOS the moment of inertia for all the formulas. You have learned in 12th itself, so you should have an idea of that. For rectangle, what is the moment of inertia? For square, for hollow sphere, what is the moment of inertia? You have to have it. So the next thing is we have seen the methods: Maculus method, integration method, double integration method. In you have to conduct double integration method. Maculus method you have to use only there is only more than one load. You use Maculus method. In double integration method, if it is only one load, if you use double integration method, you know the formula for moment, slope. If you moment of formula தெரிஞ்சாலே automatically by integrating you will find the formula for slope, deflection, etc. And you should know the boundary conditions for cantilever beam as well as simply supported beam. Then columns and studs. In case of columns, what you should have, you should first of all you should know that column is just a compression member and beam is a structural member, right? The next thing is what is strut. I have shown here. Then with either which amount short column or it's a long column. In case of short column, if it is less than 12, in case of long column it is more than 12, we should know. And for the length by divided by LLD, LLD is nothing but lateral least lateral dimension. Least lateral dimension nothing but I have told you that in case of a circular column, the radius you will calculate the you'll know you'll calculate if it is a long column or short column with the help of the radius. Or if it is a rectangular or a square column with the lateral least dimension, we will substitute the lateral dimension. That's nothing but this side. I have shown you right here. Here depth. Okay, wow. Not the full area, the depth, the value of the depth. You will substitute the value of the depth there. So in case of long column and short column, long column is determined only by the Euler's method. Euler's method is a long column. Euler's method in case of long column, the failure which happens here is called as buckling, and in case of a short king, in case of a long column, you use the Euler's method, buckling. In case of short column, Rankines method is crushing. And you know the what is radius of gyration, a simple example for the giant wheel. Then for long column, we have some edge conditions, sorry, end conditions. Both ends are hinged, and in that cases, in finding the effective length, don't forget for effective but if you will get a confusion. Which I mean, the length will be given as only if in the question if the length is given as length is equal to 3 meters, then there is no need of finding the effective length for both and fixed at cases. Suppose in case if they have not given so normally if they gave only length means we have to find the effective length for all the things. So you have to know the formula for the effective length to find the effective length for both the end hinged, both the end fixed, one end hinged, one other end is fixed, one end is fixed and other end is free. Okay, wow. We must be very clear and we must be very clear about the diagrams. Don't forget, and you also must be very clear in the finding the units. Okay, wow. Then Rankine's method, we already know that it's used only for the short formula, short column. Short column is nothing but the failure happens through crushing. Okay, wow. So we must know all these full forms: crippling, effective, Rankine's constant. In some questions, they will give the values for Rankine's method, Rankine's constant. In some cases, they may not give. So in that cases, you must be able to find. The next thing is unit 5, statically indeterminate beams. First, we have to have a clear vision about what is frame structure, mass structure, surface structures. And I have already told you should know the difference between the determinacy structures and determinate structures. Indeterminate structures nothing but it solves the equilibrium equations. It does not solve the equilibrium equations. Determinate structures nothing but solves the equilibrium equations. So you have to have the example also in mind to keep the example cantilever, simple overhanging and continuous fixed and 2 hinge with proper cantilever. Okay, then we have learned the new term proper cantilever beam. What is a proper cantilever beam? I have told you Propped cantilever, propped support not is one. It will not be only at the end. It may be also given at the center. So you must be clear about that. Then methods of analyzing indeterminate structures. You should know some methods. So have a look on this. Then types of support. Then we have seen the static indeterminacy, kinetic indeterminacy. What is static and what is kinetic? We have already know number of unknown forces available before applying the load, number of unknown forces available after applying the load. Then types of support, only three: fixed, hinged, rolled. And I have already told what only three reactions. And what are the reactions? Movement, horizontal, vertical. Here only horizontal, vertical. Roller only horizontal. That is either right answer and left answer. Okay. With the help of that, you have to find the value of degree of indeterminacy for external as well as the internal. You should keep these formulas in mind. Okay. And you must also, the very important thing is, you must know how will you represent the hinged support, how will you represent the roller support, how will you represent the fixed support. Okay, that's it, guys. Am I clear? Is there is any doubt? Anyone? Okay, all the best for your exams. I will share the notes. Thank you.